Oh, sorry. Okay, well, welcome back. Hope you had a good weekend. I asked you all to do these 4 problems, to try them and see how they went. So how did they go?
I think they went okay.
Yes? Any questions? You want me to go over any of the 4 problems?
The last one.
You want to do the last one? Okay, let's look at the last one. So for this one, right, let's see, we're recording, I'm good. Let me see how far I can go. I can go over here, and then I'm gonna go all the way to here, so. All right, so for this last one here, of course, the first thing we wanna do is the leading coefficient test, right? To figure out like what it does, left, right, up, down, you know? And we use that chart. So what did y'all get for that? Up, right? The left side goes up, right side goes up. And I had messed up that table, didn't I? Didn't I mess up that chart that first time? Yeah. Yeah, okay, so, yeah, it goes up. And then the next thing, and this is the hard step, right? Is to take this thing, find the x-intercept, so set it equal to 0. Okay, right? So first thing we always want to do when we're trying to solve an equation in terms of factoring is to try and pull a GCF, greatest common factor. So you look to see if all of the terms have something in common, in which case all of these have at least one factor of x. So I'm just going to remove an x and pull it out front. And that will leave me with x cubed plus 5x squared minus x minus 5. So all you're doing really is just removing one of the x's from each of these, right? And then on this, we have to see if what's in the parentheses can be broken down further. And I told you all kind of at the end of class that when we're doing this, we want to look at how many terms we have. 1, 2, 3, 4. We have 4 terms, and when you have 4 terms, you can try grouping. All right, so I'm going to do this on the side here. Okay, I'm going to try grouping. That's a technique for factoring. It's called grouping. All right, and what you do is you write down the 4 terms. Okay. And then right after the second term, you're going to do a little slash or a dash, whatever you want to call it. Let's see, green. So right after the second term, put a little slash there. And see, so notice that the slash is to the left of this sign. So I'm just going to focus all my attention right now on just the first 2 terms. And I'm going to see what they both have in common. So I'm going to do a GCF on just those 2. So what do both of those have in common? X squared, right? So I can factor an x squared out of just these 2. And what that will leave me is, again, I just removed 2 of the factors of x from each of these. So I'll be left here with just 1 x there, a plus, and then both of these x's went, so I still have a 5 here. Okay? Now, if grouping is going to work, and I'll just let you know now that grouping doesn't always work. In this class, it will, all right? In my other college algebra class, we're doing this right now, and when grouping doesn't work, we have a whole other method that we use to try and solve it. But it will work for you. So what I recommend you do is that you think about, well, if for grouping to work, you have to have something in front of this, x plus 5, and then over here, you're going to have an x plus 5 as well. And so what you need to do is figure out what number goes in front here, okay, what number goes in front so that when you distribute it through like this, you would get back these 2. Negative 1. So you put a negative 1 here, and now you can see that distribution of the negative 1 through here would give you negative x. The negative 1 through here would give you negative 5. Does that make sense? Yes? Another way you could look at it is just look at these 2 and factor out a GCF. The problem with that is that it is possible to miss the GCF and it not match up. It is, you know, some people may say, oh, well, there's nothing here that comes out, you know? So They don't pull anything out and they leave it, and these two things don't match. These two have to match for grouping to be valid or for it to work for us. Are there any questions on that? Once these two things match, we talked about this again last class, once they match, there's different ways you can think about it. One way is just to, whatever they have in common here, just write it in parentheses. And then in a second set of parentheses, you will put the two things that were in front. So you'll put the x squared and then minus 1. And again, you could flip this around, depending if you learn this a different way. You could put the x squared minus 1 in front and then the x plus 5 over here. Any questions? We're okay? So what we know is that this right here breaks down to be this. And then we want to just look at this and ask ourselves whether or not this is completely factored. Which is it? This can go further, right? This is a difference of squares. So we have to recognize that this is x plus 5, and then this becomes x plus 1, x minus 1. And that's just kind of a formula you have to remember, right? I think we've been through the formula a few times, but it's something like a squared minus b squared equals a plus b times a minus b. That's your difference of squares formula, and you just need to know how to apply it, right? So this is a something squared minus something squared. You can look at 1 as being 1 squared. So that's the a is the x, and the b is the 1. And then you just use the formula. So that's it. I think I'm completely factored. I come back over here. Don't forget the x out front. I have the x plus 5. I have the x plus 1. And I have the x minus 1 equals 0. And now it's completely factored. I'm just going to set each of these factors equal to 0. So I set this equal to 0. Do I need to actually solve these, or can I just put what the answers are? Just put the answers? Okay, so when I set that equal to 0, I get negative 5. When I set that equal to 0, I get negative 1. When I set that equal to 0, I get positive 1. Okay, so those are my 4 x-intercepts. What's next? Multiplicity, good. You even called it by the right name. That's correct. We're going to find out whether or not we cross or bounce, right? Or, if we're going to just touch off or bounce off the x-axis, or if we're going to cross through at each of these x-intercepts. What do I look at to determine that? What am I going to analyze here? You go back to the factors, and you look at what here? The degree, the powers on the factors. So this x is really x to the first power, right? There's a 1 there, we don't write it. This x plus 5, they're just one of them, right? There's not 2 of them in here, so there's just one of those. Here there's just one of these, and here there's just one of these. So all of the powers on those factors, right, 1, 1, 1, 1, those are all odd numbers. Right? If one of them was even, then we'd have something else happening. But because they're all odd, what does odd tell us? Cross. Odd means cross. So I just put a C here, C here, C here, C here. They all cross because they're all odd powers on the exponent, on the factors. And that's it. That's all I need to be able to draw this, right? So here comes my sketch. And on these sketches, I told you last time again that all of our sketches are going to look a little bit different. There are going to be slight little variations in our graphs, but we will all have the same common themes going on. Like we should all have the same x-intercepts. Let me put my x-intercepts on here. I have an x-intercept at 0, negative 5 somewhere over here. Negative 1 is somewhere over here. Notice I'm not even like counting like tick marks. I'm just saying, look, negative 5 somewhere over there, negative 1 somewhere right here, 0's here, and then 1 is like over here, right? So I'm not even really paying too much attention to like spacing it correctly, just making sure they're in order. And then I know that the left side and right sides both go up, right? They both go up, so I like to go to the far left point, and then just somewhere over here, I'm just going to start drawing. It goes up, And then over here, somewhere up here, it starts, it goes up like this. And now I'm just going to kind of connect these together with a smooth curve, right? No breaks, no jumps, no jagged edges. Everything is smooth and curved. And when I start drawing from here down to connect this point, I need to make sure that I cross through the x-axis. I'm going to have to turn back up, cross through again, turn back down, cross through, turn back up, cross through, and then eventually just continue through. So now that I kind of see all that, I'm just going to draw it now. So cross through, doesn't matter how far I come down, come up, cross through, and connect. There we go. Does that clarify anything that you had? Yeah.
So I got the right answer.
Okay.
I didn't do the grouping.
Okay.
I just broke it down in my head. So if on the test, do you want to see us do the grouping if we can break it down?
Well, I'd be curious how you broke this down in your head.
Honestly, I'm not sure how I did it either.
Yeah.
I did it and I got the right answer.
Yeah, so my only concern would be on a test that you would run into something that you would do in your head wrong, okay. Right? And then it's wrong, right? So the grouping is the method that we use. I can't tell if you got lucky, if I gave you a different problem, if you would get it right. You know what I'm saying?
Right. Like I said, I just
broke
it down and was able to get it.
If you want, at the end of class, I can give you another one, and you can see if it works, if whatever you're doing works.
Okay.
If it does, then I guess, getting it right twice is good, a good sign, but
okay.
Any other questions? How about over the others? We're okay? Okay, here's what I'll do. Do y'all have that ready to turn in? Okay, if you have it ready to turn in, okay, what I'd like for you to do is, if you have your phone, take a picture of both sides. That way you have a record of it. Turn it in. I'm gonna accept it for extra credit today. All right, this will be bonus on your test. We don't have a test till after spring break, but just take a picture, because that way you'll be able to review it. I'm not going to give it back till after the test, but at least you'll have some record of this, okay? And if you don't have it, you can turn it in next time for less extra credit, so it won't be worth as much, all right? So once you have it ready to go, just kind of hand them all down this way, and we'll just kind of collect them over here. Okay. Make sure your name's on it. Yeah, make sure your name's on it.
I forgot. Oops. Probably.
We're going to continue with polynomials today, polynomial functions, and then once we finish, it's not going to take us too long, we're going to start talking about rational functions. And then that'll be what we continue to do on Thursday, and then we'll have our spring break, okay? All right, so let's discuss polynomial functions, which is what exactly we've been doing, but I'm gonna switch it up on you a little bit, okay? I think you're gonna find this to be easier than what we've been doing, all right? But it's a different type of problem. So what if I asked you to sketch this function, f of x equals -4 x plus 1 squared, in parentheses, x minus 5 times x plus 6 to the 4th power. Now, this looks different than these, doesn't it? And what's different about this is that what I've given you is a function already factored. So I've already done the factoring for you. And so that step of the factoring, the second step of finding the x-intercepts, should not be hard for us, because all we're going to have to do is just set each of these factors equal to 0. That makes sense? The hard part, if there is a hard part, is that we don't have the leading coefficient test anymore. Because in order to use the leading coefficient test, you have to be able to identify the highest power of x, right? The highest power, and then the number in front of it. Those two things you need, right? Degree and leading coefficient. When I give it to you in this form, it's not multiplied out yet, so you can't tell me what the highest power of x is, and you can't tell me what the number in front of it is. Does that make sense? However, there is a quick, easy way to do this, all right? And here's the way it's done. What you do is you start analyzing each piece, all right? So -4 here by itself, we're trying to do the leading coefficient test, right? That's what we're doing here. So the -4 by itself is just the number -4, right? That doesn't ever change. That's always here. And then this, when I square that, we don't need this over here. I just want you to understand what this means. If I take x plus 1 and square it, that means I have to multiply it times itself, like this. And that means I have to FOIL it, right? I'd have to do this times this. That would give me x squared. This times this would give me plus x. This times this would give me plus x. And this times this would give me plus 1. That makes sense? This would become x squared plus 2x plus 1. Right? That's what that would become. What's the highest power of x you see here? 2, right? X squared. And that's because we started out with x plus 1 and we squared it, so the highest power we're going to see there is squared. So this right here is going to contribute something in here with an x squared. We know it's not exactly x squared, right? But the highest power we see here is like an x squared, right? That's like the highest thing we'll see there. What about this? What's the highest power of x we're going to get from this? Just 1x, right? So this really contributes like an x to this. And then what about this? What do you think would happen if I did x plus 6 times x plus 6 times x plus 6 times x plus 6 4 times? What would the highest power of x be from that? X to the 4th, right? Now I wouldn't want to have to do this by hand, right? You would definitely wouldn't want to do that by hand. But if you did, you would get something that had an x to the 4th as the highest power. So this contributes the highest power possible as x to the 4th. So I'm not saying that this turns into this. That's not what I'm saying. What I'm saying is when you put this all together, this is going to have something with an x squared, this is going to have something with an x, and this is going to have something with an x to the 4th. And when you put all those together, right, what would the highest power of x be? 7. And what you're doing there is you're just adding up these numbers up here. 2 plus 1 plus 4, that's 7. So what you really are going to get is a -4 x to the 7th. That's going to be the highest power of x you see, and that will be the number that's in front. Does that seem fair to you? Reasonable to think that it would do that? Honestly, I do not want to multiply this out 4 times unless you want me to. Y'all want me to actually expand all this out? No? Okay. I'm happy to do it, but it's going to take me a little while. So this is going to be the highest power, right? So we have a degree here of 7, which is odd. And we have a leading coefficient of -4, which is negative. So go look on your chart, and I think this is the one I had messed up on the chart, so make sure we have the right one. You have odd. Odd is always going to be one of these two. And then negative leading coefficient should be this. Left side up, right side down. Is that what y'all have? Okay. So this should be left side up, right side down, question mark in the middle. Okay? Questions? All right, so once we do that, we go and now find the x-intercepts, right? To find the x-intercepts, all I have to do is take the original function and set it equal to 0. And I can think about this the same way we've been doing this. I really just need to know what x's will make that 0, and that 0. So what x would make this 0? -1, right? If we put a -1 in here for x, we get -1 plus 1, that's 0. That would make this 0, kill everything off and make this true. Same with this one. If I put a what here? 5, right? Positive 5. We're going to have 0 there and kills everything off. And this one? -6, right? -6 will make that 0. What about this, though? what do you do with the negative 4 out here? Well, here we're saying what, these are the x values, right? These are the x values that will make this thing true, make each of these factors 0, right? And make this equation true. Negative 4 is just a number. You don't have any control over that. There's nothing you can let x be that's going to do anything to that. So this actually contributes nothing to the x-intercepts. Anytime you have a number out here by itself, you can just ignore it. But if there's an x attached to it like this, then you would have to pay attention. That make sense or no? If this, like, for example, if this was 4x right here, then yes, we would have to say, oh, if x is 0, yes, that would create an x-intercept, right? If we had an x there. We don't, so we don't consider it at all. So those are our only 3 x-intercepts. What's next? Multiplicity, right? So I'm going to go back and look at the powers on the factors here. There's a 1 there, there's a 2 here, 1 here, 4 here. So what's going to happen at negative 1? Am I going to cross or bounce? What's the power? 2. 2 is even, right? If that's an even number, even means we're going to bounce. I'm going to put B for bounce, okay? The power here is odd. When it's odd, we cross. So at this x-intercept, we cross. And then here, this is 4, that's even. Even means we bounce. So at negative 6, I bounce. And that's everything we need to draw. Are there questions? Yes? This 4 is not part of an x. Is that what you're talking about? This has nothing, this has no impact on, I cannot do anything to negative 4 to make it turn into 0, right? Because it doesn't have an x there. Negative 4 is negative 4. There's no changing to that. This, I can make this 0, right? I can make this 0. If I replace that x with negative 1, I can make that 0. 0 squared is 0. 0 times all of this is 0, so it's true. Does that make sense?
Yeah.
Okay. So anything, I can only have solutions where I can control the x. There's no x here, so here's another, if you don't like that, okay, if you want just another way of looking at it, here's something that you could do to convince yourself that this negative 4 is irrelevant. Divide both sides of the equation by negative 4. It goes away here, okay, and 0 divided by negative 4 is still 0, okay, and then it's gone. You could just basically say it vanished away. All right, I'm ready to draw. Up on the left, down on the right. I'm going to leave this here. So this function, here's what it looks like if we graph it. We're going to have 3 x-intercepts, negative 6, negative 1, and 5. There we go. Okay? Left side goes up, right side goes down. So over here, up here, I'm just going to draw an arrow like this. And then over here, down over here, I'm going to have the arrow come down like this, or my function come down. All right, now I need to pay attention to what's happening. I need to go here and draw and get to negative 6. When I get to negative 6, I need to bounce off the x-axis. So I'm going to come down, I'm going to bounce off, come back up, right? Then I have to get back down to here. When I get to negative 1, what am I going to do? Bounce again. So I'm going to bounce, bounce, and then when I get to 5, I'm going to cross. So do y'all see it? It's going to bounce, bounce, cross, and connect through. Bounce, bounce, cross, and connect. Just make sure that when you do your bouncing, that you're not actually coming below, right? That the whole idea of bouncing is like, you know, think of it like a ball. It's going to bounce off the ground and come back up. It's never going to go below the x-axis. That's it. And I said already, right, several times now, everyone's going to have different pictures. So somebody's picture could look like this. It could bounce off, come way up, bounce off, not go so far up, and then come like that. That would be a correct answer as well, right? So there's going to be all these like slight variations in people's problems. Just make sure that your final picture is smooth and curved. Notice these are not V's, right? I'm not coming down drawing a straight line with a straight line with a straight line with a straight line. Everything has to be smooth and curved. That's the way polynomial functions behave. Any questions? Let's do another one. These, do you all agree, now that you understand, all you're going to do is just kind of analyze each of these, that this is really way easier than your homework because you don't have to do the step of factoring, right? Let's do this one. I'll let you do this one on your own. Give you some time here. So how about this? I want you to sketch, how about 5x plus 4 squared, x plus 1 cubed, x, yeah, okay, x minus 3 to the 4th, x minus 7 to the 5th. See if you can sketch that. Feel free to talk to one another if you'd like to double check what you're doing with your neighbor. You can. I'll step out to give you all some time to like chit chat if you want. easier than the, yeah. Who has questions? Anyone have a question? Go another 30 seconds, then I'm just going to go through it real fast. Do you have a stopwatch on your phone? Do you have like a stopwatch? Do you mind bringing it up? Do you have a stopwatch? If you have your phone, I'm going to ask you to bring a stopwatch out, or to bring out your little timer. You know how to get it where you can like start, stop real quick if we needed to? Like start it, stop. Okay, yeah, like that. That's what I need. Anyone else that wants to participate, if you have your phone, I want you to bring out a stopwatch because we're going to do a little experiment. Okay, let me talk about this real quick. First step, leading coefficient test. So for leading coefficient test, I know that this isn't going to contribute anything except the 5. And then this is going to really act like an x squared. This is going to act like an x cubed. This is going to act like an x to the 4th. And this is going to act like an x to the 5th. So if I want to know what the power is, I need to add all these up. And I think you get 9 plus 5 is 14. So you get 5x to the 14th power. And so we have a degree of 14, which is even. And our leading coefficient is 5, which is positive. And so when we have that happen, both sides go up. And that is the real kind of tough part, I guess, if there's one of this problem, is to do that. Because now all you have to do is just take each of these factors,